Alright, hello everybody. So today we're going to do a little work grinding on the rasp knife project I've kind of been working on and off. Before I do that, I want to talk a little bit about the equipment we're going to be using today. This is a Bader BM3 72-inch belt grinder. It has various attachments for doing, like this is obviously set up as a flat platen at the moment, which is how I do most of my work around here. I'm usually just trying to bevel edges and take burrs off and whatnot, and the platen works a little bit better for that than a big wheel. If you were going to do a hollow grind, obviously you'd put a wheel on here of whatever appropriate size. I've got wheels down to about 1/2 inch diameter and upwards of 8 inches depending on the bevel that I'm trying to run. But hollow grinds are easier for the most part because once you get the grind into the surface a little bit, you normally you'd be grinding this section here. Once you've got a decent grind centered in the area you want to grind, it will tend to stay in that groove, because it's a groove. Right, today what we're doing is actually what's called flat grind. So I'll be attempting to do a flat grind starting from essentially the angle here, which should be pointed out more or less the same on both sides. And that'll bring us back close to the spine with some of this rasp details still in the blade, or at least that's the plan. We'll have a plunge cut area in here someplace, probably going through right about there, because this is going to be a Musso, and that's kind of a feature of those types of buoys. It's actually a nice spot to put it because there's actually a spot right there that looks like it's already wanting to be that cut. I'm going to clean up back here probably first along the spine of the handle area just to get this line to be more even. It'll probably, you can see it kind of rises back out here. I'll probably just grind that until it's essentially flat from this point back into the handle here somewhere. Probably should have just bent that over when I had it hot, but it looked straight at the time, so that's the breaks. Now when you're doing these kinds of grinds, if you're new to this, one of the things that kind of freaks people out is that you'll be doing your grinding for the most part blade side up. When I first tried this, I thought that was insane, and I actually tried a couple of blade side down. The problem is you can't see what you're doing, and you need to be able to see what's going on along this edge. Now, on this forged piece, you can see things are pretty wavy. So we're going to have some work to do to decide where the center of this blade is on this side. On this side, we're just going to pretty much leave things as the forging left them, so that looks pretty straight, but there's really not a lot we can do about it at this point, so it is what it is. If you're doing straight material removal method, which is fairly common for knife makers these days, then you're usually starting with a blank of tool steel. This is 01 tool steel. It's my favorite. It quenches really well in warmed oil. In this case, if you're starting from this, then obviously you'll draw out your blade pattern, and that'll be the first thing you grind out. So you'll draw out whatever pattern the blade's going to be, and you will just remove all the other material in this plane until this essentially looks like the profile of this, right? But you won't have this forged edge. You won't have this part of the bevel to start from, right? It'll still all be this same thickness. It'll just be in the shape of a knife. Now the first cut that you'll make when you're doing that for the plunge cut, if it's not a Musso like this, is probably what I would consider the most delicate part of the blade and the easiest part to mess up, because you're probably going to have ground out the handle, right? So you'll have a fixed amount of material to work with in the ricasso area, which is the part that's forward of the cross guard, but not to the plunge cut yet. That entire area there is generally called the ricasso. So you've got a little bit of material to play with, but remember, you'll be doing a plunge cut on one side, right? And then you'll be doing a plunge cut on the other side, right? So you'll have to do a plunge cut on both sides of the blade, and they have to line up, which is a bit tricky, right? So you don't want one, forward of the other one. That's going to look goofy. So once you start to get to that point, once you've outlined the blade, once you've got this dimension correct, what most people will do is they'll actually go in here and they'll either magic marker or die chem this edge, and then they'll scratch a center line down the facing of the blade, and that's what they'll watch when they're on the platen or the wheel here grinding away to see, oh, I need to spend a little more pressure and a little more time in this area and a little less pressure and a little less time in an area that's already closer to the center line. So that's how you kind of make that adjustment. Now, the weird part about the plunge cut, and I'll save you some pain and suffering here, is if you think about it, when you run a plunge cut, it cannot be straight to the wheel or straight to the grind. Why? Well, because if you just ground into this blade like this, you would be causing a dent on this side and a dent on this side. And there would be no way for you to move it once you started getting that grind in. So the plunge cut actually happens with more pressure to one side or the other, and then you're actually pushing out on that grind with the material angled, so you're pushing it into the grinding face. Now you still want to get as much of that in there as you can, but obviously it can't be flat because then you'd have this edge digging in. So that's a tricky thing, and I highly recommend you get some A36, some cheap no carbon steel, and play with that for a good long while before you go to the trouble of forging or trimming out a piece and step in here and do that, because it is a very odd and a little difficult. In fact, you can kind of do it with wood, and that's probably the easiest thing to do, is get yourself some facing, what do they call this, the straps that hide behind the paneling. You can buy those things cheap at Depot, and you can use those to practice that plunge cut, because in wood it'll immediately grab. If you go stupid and just shove it in there, it's going to be obvious what I just mentioned, what I was talking about. And if you start doing this, you'll get a feel for, oh, I see what he's talking about. There's this weird feel to, okay, it's going in, and now I'm going to have to force it down. But if I move out of going in and immediately start into a high speed, what you'll end up with is a longer plunge cut like you wanted, and then it'll tend to tail out and get to some smaller bit right as your speed goes down the blade across the face. Now that's not a problem, except you have to start fixing that. So you'll have to go from spending less time at the plunge cut to spending more time out here. It's nice if you can get the original plunge cut and the grind all the way to the tip of the blade, a decent bevel on the first pass, because if you can, it makes it a lot easier to get back into that same angle. And that's the other bit of this that can be a very, very frustrating thing, is especially with flat grinds, is what's the angle that it needs to sit at. And it's just a feel thing. You'll have to get used to it. You'll have to see. Now, for all I know, I'm going to completely screw it up today myself, but it's literally something you're like, okay, you can stare at it all day, and you'll probably see my head come in here and block the camera multiple times just as I'm staring very closely at what's going on. But it's almost a listen or feel thing once you start trying to do those grinds. Let's see, is there anything else I wanted to cover before we start making a racket? Can't think of any. So let me pause the camera. Actually, I'll just put the piece down. All right. So the machine itself, again, is a 2x72 grinder. One of the nice features of it is you just push this lever down to take the slack off the slack wheel, and the belts pop right off. You put a new belt on. There's arrows on the belt. Those need to be observed, or else this little piece here will have a tendency to come unglued on you. That's a very exciting thing to have happen if you are directly in front of the belt when it happens. I will tend to get these on here and then start it. You make adjustments to the belt, the piece way up here. It basically changes the alignment of the idler belt. Okay, so this is a 36 grit 2x72 inch belt. This is what I consider the most dangerous piece of equipment in my entire shop. And I have done some really stupid things with this piece of equipment and paid for them before. I've got a lovely scar here where I essentially dropped off of a piece, small piece, and stuck my whole finger into a fresh 36 belt like this, and it turned the entire end of the finger into flayed meat. So if you get one of these, or if you have access to it, please treat it with respect. All right, so we're just going to go right into it. I'm going to probably start by cleaning up a lot of the profile areas, and then we'll go into the face grinds. I've got a piece of, this is actually like I call it a mud tray that you can get at Home Depot, for instance, that I've got over here. And you'll see me shoving the blade in here quite frequently. That's because while the blade is currently in a normalized state, meaning it's not hard, well, it's not very hard, it's actually a little harder than I expected it to be, it can get hot in this temperature and go back up into a range where it will be doing damage to the blade itself. So I don't want that to happen, and that's one of the reasons why I don't have any gloves on. The other reason for no gloves is it's just a mess. So if you're going to do this, my advice is don't go gloves. Gloves around this kind of equipment are dangerous anyway. They tend to drag you in if they get hung on stuff. Not as bad as a drill press or a mill or a lathe, but still, you don't want to get drug into your equipment or have your fingers between here. That's a bad thing. And so if your hands are, if you don't have gloves on, you can feel when that heat starts to rise up the blade, and that's a good thing. So when it feels like it's getting warm, it's time for it to get dunked and move on. I don't know if you can hear me or not, but you may notice that it goes, like when I'm moving across these flat sections I've ground already, adding to these areas that still have sharp edges on them, you'll hear the blade start to hit, or sorry, the belt start to hit. And that's another good indicator that you're not on your bevel grind. You hear a higher pitch noise rather than a kind of a dull grind, you're probably on one side or the other of your grind, or you're working in an area where there's a lot of this kind of tooth-like stuff. So I'll do that again. You can kind of see if you can pick up on it. But they were nice and dark, right? Not making a lot of noise at all. And you hear it start to hit. By wiggling back and forth, you can hear it as well. I'm pretty happy with that spine. It's fairly straight. Still got a little bit of a dent in here, but I think it's going to disappear with the handle in place. And there's a couple more lines here, but I may grind those a little deeper. I haven't decided yet. There's going to be I assume it's copper, maybe it's bronze. It looks like it's copper to me. Piece that'll be over the back of this. I think the copper is going to patina better, so and obviously it'll have, again, probably whether that piece is brass or copper, it'll have the same piece here as a crossguard, kind of probably an S thing. I think that seems to be the more popular Musso look, or just a dead simple piece. I figured out a puzzling way to get rid of this problem of getting the thing on from the rear, and that is, it should have been obvious, is you just cut the rectangle through the guard to barely fit over whatever this ends up being at its maximum width, and then you cut the slot in this piece here that it fits onto to match that same distance. Very simple. And then I think that's probably why most of these you see a small brass bolster area behind that's pinned, is to give that piece, rather than having it against whatever wood, or in this case it'll be bone material, lives on the handle proper. You get that anchoring point of a piece of metal that's pinned and forced up against that piece. So that's